Hello guys, and thank you for being here. So this is module number 5 and it will entail data visualization, and we are going to look at basic graphs such as histograms, scatter plots and line graphs. We are also going to look at bar graphs and pie charts, and instead we use graph bar and graph pie to plot both bar and pie charts respectively. We're also going to look at box plots. I'm also going to see how we can customize our own graphs, like adding titles, labels, as well as legends. And finally, on how to export these graphs for later use using the graph export command. And moving ahead now on basic graphs, we'll start with the histogram. And remember, histogram is used for visualizing the distribution of a single variable. For example, if we can plot a histogram of income based on this line of code, you just need to issue command histogram income, and as I told you previously that after a comma, almost anything after a comma in STATA is visualized as an option. So we want this histogram for income column to have 20 bins and to follow a normal distribution. And we have now scatter plot as one of the basic graphs. The scatter plot will display the relationship between two numeric variables, and the example that two numeric variables are based on our data set is income and age. So if we just say scatter income and age, we get a scatter plot representation of both income and age. And we have now line chart, or sometimes line plot, and this one is used to plot trends over time or across observations. Example, instead of, if you want to print or to plot a line graph of GDP per year, you just need to write line GDP and year, and we'll get a line plot. And now let us look at bar and pie charts. Instead, we use graph bar to create bar charts for categorical or group data. For example, we can use this command in STATA to plot a bar plot of income versus gender. You just need to say graph bar income comma over gender. As well, you can also plot pie chart instead of using graph pie comma over region. For example, it will be a pie chart representation of regions. And the moment you issue graph pie, STATA will know that you want to create a pie chart. And remember, pie chart is used to show proportions. And now box plot. For box plot, STATA will visualize data distribution and will identify the outliers if they are. And example, we can have something like graph box income over education. So this one will be a box plot of income based on level of education. And now we're moving to customizing our graphs. So there is a way we can customize our graphs to make them look fancy, representable, and maybe you can say international standards or industry standards. So we can customize graphs with options like titles, axis labels, as well as legends. To add a title using STATA, we just need to issue title and the name of the title you would like. So for example, this will be a title of income distribution. And axis label, for example, if you want to add Y label, you can just issue the command like Y label 0, 1000 to 10,000. It means that this Y label will start from 0 and it will go straight to 1,000, 2,000, 3,000, all the way to 10,000 as the maximum. And X label can also be represented the same like Y axis, but now we're being told that we're starting from the origin with the gaps of 10, 10, which means 0 to 10, 20, 30, all the way to 100. now we have legend. Legend is like a key. So to add a legend, we just need to issue a command legend. Label 1 should be male and label 2, for example, might represent female. And we can have now a combined scatter plot like this with now all these customized items. Just say scatter income age and then comma. These are options. Now we want to add a title which will represent income versus age. X label which will start from 20 to 30 to 40 all the way to 70, and Y label will start from origin to 1,000 through 10,000. And the legend of now, we don't want a legend. And let me tell you something, that we are having this three slashes tells data that the next line is part of this line. So it means that this line is part of this. And the moment we issue these lines, we realize that the data will still understand that they are part of this previous code, and it will respect that. So if you plot the graph, it will still make sense. And remember, it's optional to do these sections, like this line to end at this position. We can still proceed from this, so like one continuous line without commas. So it'll be like this X label will start from here, and we space Y label and we space legend. But now for easier readability and understanding, that's why we have to break down into sections. And now we have how we can export the graphs. Imagine you are just visualizing these plots, but it's good to use them in your reporting. So it's good as well to export them for further usage. So we use graph export command. We use graph export command in STATA when we want to save graphs in various formats, and this format might include PNG, PDF, SVG, among others. But remember, I've just used capital letters or uppercases. But when saving, you need to use lowercase extension. So lowercase extension, if you use uppercase extension, STATA will complain and you will not manage to save that. So make sure that you stick to lowercase when saving the graph. And to save a plot, for example, in STATA or to export, you just need to issue the command graph export income. For example, this will be the name of the chart, income underscore chart dot png, comma replace. We are telling STATA to save this plot, that to export this plot, and it will replace any existing plot, if any. And now it is now time to proceed to our practical part. So let us see. Now I've opened my STATA. Let us open our do file so we can proceed. So this do file is the equivalent of module number 5 theoretical, but now this is practical part. So it is about data visualization, and this is still our file path. So the first thing first, we need to load our data, and by just running this line, this line, and what follows now after running after importing our data or loading our data, what follows is now to check if the folder exists or you want to create another folder. So the reason we're doing this is that we want to create an exclusive folder where all the plots will be generated. So for our case, this is our master folder, and we have this folder called graphs, where all the graphs will be displayed or saved. Now let me delete this. Yes, I have successfully deleted it, and now it is time to create. So this command will create a folder called graphs in the current working directory. So upon issuing this command, it will create a new folder. So let us create. We realize a new folder has been generated. This at date 19 of July 2025, 7:25 a.m. And what follows? What follows now? We need now to cd or to move to this directory. So to move that, we need just use cd, which stands for change directory. Now we want to be working directly to this folder directory. And now what follows is now to create the basic graphs that we were looking at in theoretical part. So to create a histogram, we told that this is how we need to use this command to create a histogram. This will be a histogram of age, and we're creating it to have 5 width, and the frequent title will be the age distribution, that is the y-axis, and x-axis will be title, will be age, y title will be frequency. And now what follows that we want to export this graph using graph export, and the name of the graph will be histogram underscore age.png, and we want to replace if anything is of similar is in the current directory. Command window is not going to be displayed in result window, but it will be displayed in a different window called graph viewer. So this one is exceptional. It will never be displayed in the result window. So I've issued the command, and let us wait as it processes. Yes, we have our graph of age distribution and frequency. Age distribution and frequency. So you realize majority of people are aged between okay, I can say 40 years and below. This is why we have maximum frequency, 40 years and below. And now the good thing is that let us now try and check our directory called graphs. Now I had deleted previous, but now we have this, a new plot has been saved here. And now again we want to create another histogram, but now this time with different naming, also different file extension. We are using .svg. So the reason I'm doing this is that we want to compare these two plots. And now let me go to this graphs folder. We realize we have two graphs, and I will open all of them. This is so this is the .png histogram. I want us to see the quality. So let me zoom in. I'm zooming in, and I hope you are seeing how it is depreciating in quality when I zoom in, but when I zoom out, the quality retains. But now let us try and check now our .svg graph. So this is the .svg graph, and let me try to zoom in. You realize the more I zoom in, nothing happens to its quality. The quality remains intact. The quality remains intact. So the .svg graph is not affected by the quality of the graph. So it doesn't matter how much you zoom in or how much you zoom out. The quality will remain intact. While the .png or .jpeg, something like that, will affect the quality because those they're made up of pixels. But in .svg graph are unpixelated graphs, so which means that it's not made up of pixels. Let us compare the one with the pixels. That is that is a PNG graph. So these pixels are seen here in the title. You can see something like some parts are being represented as boxes, small boxes. So those small boxes are an equivalent to pixels. I hope now you understand which kind of plot will you rely on based on your preferences. Just a point of note, I told you something about these three lines in a theoretical part, and I'm still reminding you here that these three lines is just it shows that it's a line continuation symbol, and it tells theta that the current command continues to the next line. So like this one tells that this line does not end here, it proceeds to the next, and again it also to proceed to the next line. And now what follows is that we want to plot a scatter plot, and scatter plot in STATA is issued by this command. Just scatter and then your two continuous variables, and our two continuous variables are income and age, and we need to add a title like income versus age, x axis versus like age, and y axis as income in USD. And now we can also export the graph as .png. So running this graph, we get this scatter plot of age versus income, and general trend shows that the old guys are highly compensated than the younger guys. So the higher your age, the higher the compensation scale. And now it's also time to come up with a bar plot of income versus region. So we want to see how these people are compensated based on region. And now we also need to save the plot. So we realize that the west region is highly compensated than any other region. West region, south, north, and east. So the income distribution for each is least, and then followed by north, south, and west. As well, you can also do, we are also going to do a pie chart of employment. So you see how employment is distributed. So you realize that from this plot, employed guys are taking higher proportion of 40%, while self-employed and unemployed are taking each 30% of all the sample size. And now let us again plot our box plot. So we said to create a box plot instead, we just used to write the term graph box, and for example we want a box plot of income over gender. So how is compensation distributed over the gender? So running this, we realize that basically male earns higher than female based on this line, which is the median. But if we look at individually, you realize that the least compensated guy is from the male group. You see from this, earning below 30,000 USD. But we realize that both male and female earn the similar higher scale, which is 60,000. The maximum earner comes from both groups, male and female. And now what follows, you want to create also a graph box or a box plot of age distribution over region. To see how where are the younger guys and where are the old guys from these regions. So we realize that these are the region age representation for each and every region: east, north, south, and west. So generally, looking at this line, the horizontal line, you realize that the old guys, most of the old guys comes from west and youngest guys comes from south, and the oldest guy comes from north again, and the youngest guy comes from north as well. Now it's time to come up with the line graph. And to come up with the line graph should be, we want to create a line graph of income versus year. And to do so, we have 3 years. Let us first of all visualize our data. We need to browse. The year ranges from 2020 through 2022. So 2020, 2021, and 2022. So we want to get the average of each year. For example, 2020, you need to get the average. For example, this is 2020. We have something like income 30. So we will take all the instances of 2020. Under this, we have also another 2020, another 2020 here, plus another 2020 here, all the way from any instance of 2020, and then we divide by the total instances. We'll get the average, and we'll do this the same to 2021 and 2022. That's what this is what I'm going to do here. That first of all, you need to collapse mean of the income, but will be based on the year. And upon running that, this is the result we are going to get. This. And now what follows, now we want to get the line graph of income versus year. And plotting this, now this is the line graph showing a negative trend from 2020 to 2022. And guys, this is the end of module number 5. Thank you for being here, and see you in module number 6. Thank you.